Hello friends, our today's topic is electric motor. Electric motor is a device which converts electrical energy into mechanical energy. We have seen this in our daily lives. Let's take an example of mixer grinder. What it does, it takes our electricity and then converts this electrical energy into mechanical energy. Means it converts this electrical energy into rotating that blades, which in turns grind your objects. Now, whenever we talk about any machines or any equipment, we talk about four things. First is what is its principle, what is construction diagram, what is its working, and where it is used. So let's see one by one. First, its principle. Principle, it works on the principle of a force of magnetic field. So when a current carrying conductor is placed in a magnetic field, it experiences some force. Now, why this happens? When a current is passed through a conductor, it creates a magnetic field around it, and this conductor is placed in magnetic field. So one magnetic field due to the current and one magnetic field due to the magnet. These two magnetic field interact with each other and they exert force on one another. That's why the conductor starts rotating. Now let's circuit diagram. Here it is the schematic diagram of your electric motors. So let's see one by one what are their parts and what are their applications, why they are used in our circuit. First we have armature. Here you can see the coil A, B, C, D. This is the armature. This is nothing but a conductor. Now principle is conductor is placed in magnetic field. So we must have magnets. So magnetic poles north and south is used to set up the magnetic field. Now the two ends of this armature coils are connected to two rings, which is C1 and C2. These are in C-shaped and they are not connected to each other. These are disjoint C-shaped rings. These two rings are in contact with two brushes, which is B1 and B2. They are just in contact. They are just touching that rings. Now the purpose of their brushes is basically they transfer current from external circuit to the rings and armature, and from armature and rings to the external circuit. These brushes are made up of carbons. Why? When there is a contact between a fixed part and rotating part, the friction occurs. And when the friction occurs, there is a chances of wear and tear. So carbon acts as a lubricant, self-lubricant. Carbon is a self-lubricant, so it reduces the frictions and it helps in that rotating ring. So friction is very, very less, so our loss is less. Then we have this axle, or we can say the shaft. It is basically a pipe type structure on which your entire armature is mounted. Here you can see a straight line. This straight line is basically nothing. It is an axle. And the last, we have to supply the current to the conductor, so we must use a battery sources to supply the current to the armature. Now how it works? The conductor is placed in a magnetic field. So this conductor, if there is a current in this conductor, it will experience a force. And in order to find the direction of force, we use the Fleming's left hand rule. So let's say we have this coil. In this side, the current is going in upward direction. The current is going in upward direction, and the magnetic field direction is always from north to south outside a magnet. So if you keep your left hand in such a way that your first finger is representing from north to south, and the second finger is representing your direction of current, which is upwards. So the direction of thumb will be inside this screen. So the force is getting applied on this side is the inside of your screen. If you just take the other side of the coil, your armature, the current in this armature is in downward direction, but magnetic field is from north to south. So if you just see using your Fleming's left hand rule, so force in this segment, force in this second segment, which is in your right hand side, the segment is applied outwards, like towards you. So one part of the coil is applying force inside and one part of the coil is applying the force in outside. So there is a rotating twist here. So that's why these coils starts rotating. After half cycles, the left part becomes right and the right parts become left. So again the force we feel in the same direction, so it keeps on rotating. In order to visualize, we can use this. You can see these diagrams like how it is rotating. The force is getting applied downwards, and on that side force is getting what upwards, so this is rotating. Then again, after half rotations, your coils are getting interchanged. Again, the force will applied on one side, and in the other segment the force is applied on the upper hand, so they keep on rotating. Now with these two rings, C1 and C2, these are disjoint, they are not connected with each other. They are also rotating, and they are just in contact with these two brushes. They are just touching brushes, just touching these rings. They are not welded or something. They are just touching it. So what are the purpose of brushes? To take the current from external circuit to the armature, and armature to the external circuits. And the rings provides, basically it helps in the rotation of armature. So we use the Fleming's left hand rule here to determine direction of forces. Now here I have written the working, how it's performing, how the current is going, how we are applying in the words. You can just go through it. Now let's come to the application part. We use motors in our daily life at many places. In almost all your electronic appliance, we use the motors. For examples, we have already seen a grinder. We use it in the water pump. We use in the car. We use in the beauty apparatus. We use it in the electrical tools. We use in your floor meals. We use in this your computers. Every appliance we use these motors. So we have huge application of electric motors. Now there is a difference between electric motors which we saw here and the commercial purpose. Now in commercial purpose, electromagnets are used instead of permanent magnet. Here we used a magnet which is having only one north south pole combination, but in electromagnets we can have many poles also depending on their type of formation. Now instead of only one armature coil, we use lots of armature coils, and the center part is not empty. Here if you see in this diagram, inside your armature coil there is a circular cylindrical shape that is called your soft iron core. It is used to enhance the power of our motor. And the armature have large number of coils. Here you can see in the diagram there are lots of coils, not single turn, they have multiple turns. So this is basically three difference between commercial motors and your the motor we just saw using schematic diagram. Now let's talk about the types of current. Current we do have of two types. One is called alternating current and the second is called direct current. Now what do you mean by alternating current? Alternating current is a current which reverses its direction after regular interval of time. If there is a change in the direction of current, let's say it's going towards east, and then after some time you are going towards the west, then again you are going towards east, then again after some time you are going to the west. So this shift in the direction, it also happens in case of current. So the current which reverses its direction after regular interval of time is called your alternating current. And its magnitude is not fixed, its magnitude is variable. Here you can see some forms of alternating currents. First one is sine wave in the form of a sine function. Then second is some random complex function. Then we do have a triangular waves. Then we have square waves. Here the important point is after a regular interval of time, direction is continuously changing. First it is going upwards, that is in positive direction. Then after some time it's going in negative direction. Again it is repeating. Its direction changes, that is it's going towards positive, then again negative. So this each and every interval of time there is a change in the direction, so such current is called alternating current. Now one positive and one negative, your segment makes one cycle. Here if you change from positive to negative and again positive, till this point you change again to the original direction, that point is called one cycle. So one cycle comprises of two things, one positive cycle and one negative cycle. A complete cycle have two half cycles, one is positive and one is negative. This one positive and negative segment completely is known as your one cycle. So in India the frequency of AC is 50 Hertz. It means in a 1 second there are 50 such cycles. In America or some countries, they use 60 Hertz frequency. So basically, there is nothing, there is no advantage or disadvantage. It's just a standard convention we use, but depends upon this frequency, your electrical or equipment's design differs. So in India, the frequency of AC is 50 Hertz. It means there are 50 cycles of alternating current in 1 second. And the most common which we use is your sine wave curve. Second form of current is direct current. The current whose direction does not change is called direct current. Here, the magnitude may change or may not change, but direction will always be same. So DC have two types. If its magnitude remains constant, then it is a fixed DC. If its magnitude is variable, then it is called variable DC. And the basic concept is the direction must not change. Here you can see in the first diagram, here we have the pure DC whose magnitude is constant. For example, if you're getting 5 ampere of current or say it's supplying 10 voltage, then it will be fixed throughout. But in case of variable DC, we do have some fluctuation in case of voltages. Here you can see the voltage increasing, decreasing. Here it is in the form of pulse. First it's 0, then it's 5, then again 0, then 5. But direction is always positive here. Direction is not changing. Now let's talk about some basic differences between alternating current and direct current. First factor is frequency. Since alternating current is changing its direction, so we have either 50 or 60 hertz, depends upon which country we are using it. Direct current, since there is no change in the direction, the frequency of direct current is 0. Second, direction की बात करते हैं. So direction, it means alternating current reverses its direction while flowing in a circuit, while direct current, there is no change in the direction, it always flow in one direction. Current, the magnitude of alternating current changes continuously with time. So direct current, in general we talk about fixed DC. So fixed DC, in case of fixed DC, there is no change in the direction of current and there is no change in its voltage level also. The magnitude constant, but we do have the variable DC also. Now transmission purpose, for example, if you want to transfer the power from one city to another city, then alternating current is used because the losses in alternating current is very much less compared to DC, and it is very easy to transfer alternating current. So direct current is not used for a transmission purpose for take a far because the losses are very high. And the alternating current, all the generators are by default alternating generators, and the supply means they produces alternating current, but with the help of some special arrangements we can get DC current from generators also. But in general we use the battery and cells. In your homes, your inverter batteries basically supply your direct current, and all the cells we use in clock, in remotes, everything that supply current in the form of DC. Now let's talk about the basic domestic electric circuit, like how current comes in our homes, how it is used, how it is distributed. Now first we take a wire from your poles from your supply of electricity board, and this goes to your fuse board. You must have seen your fuse board outside in the beginning of your house, somewhere in the out near your main gate, where there is a huge box in which there are lots of distribution occurs. So this go first in the fuse. First it goes to the fuse board, then it goes to the electric meter box, and then the distribution box, which is in front of your house or in the front area of your house. And then from the distribution box we decide like which wire is going into the which room, and depending upon their capacities. Nowadays this electric meter is placed at before your fuse board also, in order to prevent your electric theft. Now here you can see there are three types of wire. One is called live wire, second is neutral wire, which is negative wire, and third is earth wire. So we in electric terms, electricity flows only if there is a complete path. So if the current is starting from the one terminal of a battery, it must reach back to the same terminal. That's why we have to use two wires. One is called live wire. Live means the current is coming from this live wire, and negative neutral wires means the current is going back from this neutral wire. So let's see one by one. Three types of wire. My first is live wire. Here the color is very important. The color of live wire is generally red in color. It is the wire from which the electricity is coming to your house. Second wire is the neutral wire, which is generally is a black or blue in color, and the current goes back to the original place from where it's coming through the neutral wire. So basically neutral wire completes your circuit. Now we have one more third type of wire also. You must have seen in like big appliance, not in your mobile charger, there is only 2 pins because the current drawing or capacity is very less. But in case of large appliance, for example your motor, your AC, we use 3 pins. So there is one more extra wires in case of heavy equipments. What it does, first it's generally green or yellow in color. Now it is connected to a metal plate in the earth near your house. It acts as a safety measure for your gadgets. Now when there is an excess current, when there is a high voltage, there is more charges. So what it does, it takes the extra charges and directly transfer it to your earth. Thus what it does, it prevents shock, it prevent damage to your body. So earth wire, the third wire, is basically is a safety measure. Now we use one more thing in our house, that is fuse, which also acts as a safety measure. It prevents your circuit, it prevents your take a home appliance. You might have seen sometimes, like whenever there is a sudden surge of current, we use too many appliances in a room, then suddenly the MCB of that room gets tripped. Then we go in the distribution box, just reset your MCB. But if you increase the load in a particular room, sometimes this fuse works in order to prevent your all the appliances. So what is this basically a fuse? A fuse is nothing, it is just a safety measure. So whenever there is a high voltage fluctuation occurs, there is a short circuit, there is a overloading, there's suddenly increase in the flow of current, then the fuse operates and it saves your electrical gadgets. How it saves? There is basically a wire is connected in the fuse. So as the amount of current is increasing, what it does, according to the Joule's law of heating, it starts producing heat, and that heat melts down that fuse wire. Now fuse wire have high resistance and no melting point. So fuse wire must get melted if there is a high amount of heat is passing through it. So the fuse wire have high resistance and low melting point. Now due to which when excess current is passed through them, they melt easily and prevent our appliances. Now this fuse is always connected before the appliance, because we have to save your appliance. If you connect after your appliance, there is no use of it. All appliance is already damaged. So fuse is always connected before appliance and in live wire, because the live wire is the one which supplies your current to the devices. Here you can see there are two types of we have fuse. First one is, this is the old one, in which we have to do mechanical wiring. We just connect these two terminals through a wire. So when there is a fuse occurs, like a fuse gets melted, again we have to take it out, and then manually we have to reset, manually we have to fix the wires. But nowadays it's like a switch. Whenever there is an excess current, the switch operates and it trips down, which it means like there is a breakage of a circuit, and when there is incomplete circuit, the current doesn't flow through it. So what we do, we just like a switch off of your fan or any device. When we do switch on, current starts. When we do it to switch off, then current stops. Same like MCB. When MCB is down, then there is no current. When just if you just push it upwards, the MCB is upwards, it means the circuit is complete and there is a flow of current. Now we have used one term here, short circuit. What do you mean by short circuit? Whenever there is two or more unwanted wires comes in contact with each others, now then short circuit occurs. Generally we can say the live wire or neutral wires comes in contact with each others. So what will happen if the live wire and neutral wire comes in contact with each other? We have seen in electrical chapters, like current flows that path in which it have least resistance, and when there is no current in the path, all the current goes through it. So if the short circuit occurs, these wires comes into contact directly, then what happens, they bypasses the circuit, they bypasses the resistance. So suddenly the value of resistance reduces and it increases your current drastically, because current depends upon your resistance. If there is a less resistance, then the amount of current flow will be high. So in the case of short circuit, resistance reduces because the appliance which is drawing the current have some resistance, and the resistance is in no use now. If there is no resistance used, then the current will increase drastically. So it produces enormous amount of heat, and we sometimes see the sparks, and if the conditions are not good, then we can even see the small fire. Now how do we calculate the fuse rating? We cannot use same fuse for a mobile phone and the big motors, because a mobile phone, it draws a very less amount of current, while the AC and your water pump, all they draw very high amount of current. Let's take an example of your mobile. Let's say it takes a 2 ampere of current. You have used 5 ampere of fuse for it, but in order to operate your motor, you must have at least 10 ampere of current. So as current reaches 5 ampere, the fuse will work. So 10 ampere of current will never be reached to your appliance and it will not operate. So we have to use fuse rating for different purposes, depends upon the appliances. Now, how do we calculate these fuse ratings? First, and let's take an equation. An electric oven or 2.5 kilowatt power rating is operated in a domestic circuit of 220 volt. We have to calculate its fuse rating. So in order to calculate fuse rating, first we have to determine how much amount of current is drawn by this appliance. So how do we calculate this? First, given is power 2.5 kilowatt, it means 2500 watts, and voltage is 220 voltage. So we have to use the current by the formula P upon V. We know that power is equals to V into I, so we can say that I is equals to P by V, yani power upon voltage. So 2500 divided by 220, if you solve this, it comes out to be 11.36 ampere. Now fuse rating must be slightly greater than this. So we can use 12 ampere fuse for this, or if we have to use somewhere near like some standard value, we can use even 15 ampere of fuse with it. So with this, we have seen today electric motors and domestics your circuits. Thank you very much. In the next video, we'll talk about electric generators and the principle of electromagnetic induction.